Hello grade 8. For today, we will be discussing simplifying rational algebraic expressions. In today's lesson, you should be able to identify and simplify rational algebraic expressions. Before we proceed on that, let's have a short recall in simplifying fractions. We know that if the numerator and the denominator is the same, that is equivalent to 1. And then, if the numerator and the denominator are not the same, we can express it into lowest term. How can we simplify it? We can write the factors of the numerator and the denominator and cancel some factors. For 7, we have the factors of 7 and 1. And for 14, we have the factors of 7, 1, and 2. We know that 7 and 1 can be cancelled. Therefore, our answer would be 1/2. The simplified form of 7 over 14 is 1/2. Next is 15 over 25. The factors of 15 are 3 and 5, and the factors of 25 is 5 times 5. We can cancel out 5 on the numerator and cancel out 5 on the denominator. Therefore, the simplified form of 15 over 25 is 3 over 5. Last is 6 over 21. We know the factors of 6 are 2 and 3, and for 21, we have 7 and 3. We can cancel 3 on the numerator and on the denominator. Therefore, we have 2 over 7 as our lowest term. Now, when we say algebraic expression, it follows the form n over d where n and d are polynomials and d is not equal to 0. It can be thought of as a fractions having polynomials in either numerator or denominator. The same rules applies in algebraic expression when we're talking about rational numbers. Here's an example of rational algebraic expression. We have here the numerator and we have here the denominator, and both of those are polynomials. Simplifying rational algebraic expression are similar with simplifying fractions such that common factors from the numerator and denominator are divided to get 1 or to get cancelled out. In simplifying rational algebraic expression, one should look for common factors, factorable quadratic trinomials, and factorable special products in order to check whether the expression is simplified or not. Before we proceed in simplifying rational algebraic expression, let's identify first whether the following are rational algebraic expression or not. X squared plus 1 over 2x. This is under RAE or rational algebraic expression because the numerator and the denominator are both polynomials. Next, 2x plus 1 divided by 1 over x. This expression is not a rational algebraic expression because we have a variable on the denominator of our original expression. That is not applicable when we are talking about rational expressions. Next, we have x squared plus 2x plus 1. This expression is under RAE because this is a polynomial with a denominator of 1. Therefore, it can be expressed as x squared plus 2x plus 1 all over 1. Another example is 2x plus 1 divided by the square root of quantity x plus 1. This expression is not under RAE because we have the square roots in the denominator. Always remember, square roots and variables on the denominators are not allowed in rational algebraic expression. Another is x plus 3 divided by 5. This expression is under RAE. We have here 2x minus 1 divided by 0. This expression is not RAE because the denominator is equal to 0. Always remember, If we divide a number to 0, the answer would be undefined. For example, if we have 3 divided by 0 equals to x, then it means that 3 is equals to x times 0. There are no possible number that can be replaced to x, thus it is called undefined. Another example is 0 divided by 0. This is also not an RAE because dividing 0 by 0 would be indeterminate. If we have 0 divided by 0 is equals to x, then it means that 0 equals x times 0, meaning all possible numbers may be replaced to x, which makes it hard to determine the value of x. Thus, it is called indeterminate. We observe that the following expressions are not rational algebraic expression because the denominator are 0. Now, let's find the domain of rational algebraic expression. But what do we mean by domain? Domain of any rational algebraic expression is always the set of real numbers except the values of x that make the rational expression undefined. For example, we have here 4 divided by the quantity of x minus 3. What are the possible values of x that would make the expression rational, and what is the values of x that will make the expression undefined? So for us to know that, we will just copy our denominator and equate it into 0. We have x minus 3 is equal to 0. For us to get rid of negative 3, we will apply addition property of equality. APE states that we need to add positive 3 on both sides to get the value of x. Therefore, x will be equal to 3. And our domain would be x such that x is a real number except positive 3. What do we mean by this? Meaning, any value of x will satisfy our expression except for positive 3. Because when we input positive 3 on our denominator, it will be equal to 0. And that will make our expression undefined. Another example is x plus 1 over x plus 5. For us to get our domain, let's equate our denominator to 0. Let's apply the same rules. Let's use APE. Let's add negative 5 on both sides. So we will have x is equal to negative 5. Therefore, our domain would be x such that x is a real number except negative 5. Meaning, any value of x is applicable except negative 5. Because if we input negative 5 on our denominator, it will make our expression undefined. Let's have the last example. We have here 2x plus 1 divided by 2x minus 3. To get the value of x, let's equate our denominator to 0. Let's add both sides positive 3 and we will have 2x is equals to 3. To get rid of our leading coefficient which is 2, let's multiply both sides by 1/2. Therefore, our answer would be x is equals to 3 over 2. Therefore, our domain would be x such that x is a real number except 3 over 2. Meaning, all possible values of x is applicable to our expression except 3 over 2 because if we will input it on our denominator, it will become undefined. Now, let's proceed on simplifying rational algebraic expression. Take note that when simplifying rational algebraic expression, always look for common factors, factorable quadratic trinomials, and factorable special products. Let's have the first example. Let's simplify 12x raised to the 4th power divided by 4x cubed. We know that the factors of 12 are 3 and 4, and the factors of x raised to 4 are x multiplied to itself 4 times, and the factors of 4 are 4 and 1, or it can be 2 times 2. But here in these circumstances, I choose 4. And then the factors of x cubed are x multiplied to itself 3 times. As you can see here, we can cancel positive 4 and we can also cancel these x's. Alright? Therefore, we will have 3x as our simplified form of 12x raised to the 4th power all over 4x cubed. Another example is that we have 12a cubed b squared divided by 30a squared b raised to the 4th power. The factors of 12 are 6 and 2, and the factors of a cubed is a times a times a, and the factors of b squared is b times b. We also know that the factors of 30 are 6 times 5. We will just write down the factors of a squared and b raised to the 4th power. So we will have this kind of expression. We can cancel 6 on both sides, and we can also cancel 2a's and 2b's. Therefore, we will have 2a divided by 5b squared. How do we come up with 2a? Because we multiply the remaining coefficient and variable on the numerator, which is 2 and a. We multiply the remaining coefficient and variable on the denominator. 5 times b is 5b times b is 5b squared. Next, let's have 2x plus 4 divided by 6. We know that 2x plus 4 has a GCF, therefore let's factor it out. The common monomial factor in 2x plus 4 is 2, and the remaining factor would be x plus 2. And we can also factor 6. The factors of 6 are 2 and 3. As you can see, we can cancel 2 on both sides, therefore we will have x plus 2 divided by 3. For our next example, let's have 10x squared minus 15x. We know that the GCF of 10x squared minus 15x is 5x, and the remaining factor is 2x minus 3. We can also factor 20x by having 5x times 4. As you can see, we can cancel out 5x on both numerators and denominator. So we will have 2x minus 3 divided by 4. Our next given is x squared plus 7x plus 10 divided by x plus 5. We know that x squared plus 7x plus 10 is under quadratic trinomial, so we can factor this out. The factors of x squared plus 7x plus 10 is represented as the product of two binomials, which are x plus 5 times x plus 2. And we can copy our denominator because it is not factorable. And as you can see, we can cancel x plus 5 on both numerator and denominators. Therefore, we will have x plus 2 as our simplified form. Another example is x minus 3 divided by x squared minus 2x minus 3. X minus 3 on the numerator is not factorable, so we will just copy it. And then x squared minus 2x minus 3 is under quadratic trinomial, so we can factor it out using the product of two binomials. So we will have x minus 3 times the quantity of x plus 1. As you can see, we can cancel out x minus 3 on both numerators and the denominators. Therefore, we will have 1 over x plus 1. It's your turn. Simplify the following rational algebraic expression. For letter A, we have m squared plus 5m plus 6 over m squared plus 4m plus 4. For letter B, we have x cubed plus 8 over x squared minus 4. Pause the video for a while and we will reveal the answer afterwards. Here are the answers on our exercises. For letter A, we have m plus 3 over m plus 2. And for letter B, we have x squared minus 2x plus 4 all over x minus 2. Do not forget to access your Quiver account for a short assessment. Thank you and God bless.